factorize the following algebraic expression. For this question, one must have to take the common factor from each terms. So let's have a look for question number 1 here. 3x plus 12. So what you'll have to do, you'll have to take the common factor from each terms. While taking the common factor, you'll have to remember that we must have to take the highest common factor. So let's have a look with this constant value. 3 and 12, both these are divisible by which table? Yes, that is the highest is 3. So we take here 3, the highest common factor from these two terms. Apart from that, here the variables x and here without x, which means we can't take here the letter x as the common factor. So we can take here only the highest common factor will be 3, which is our highest common factor here. After that, here we divide this one. So 3 into how many times is, that is 3 into how many times equals to 3? Yes, that is 3 into 1. So 1. After that, we left with x plus, again we divide this one. 3 into how many times? Yes, 4. So after taking here 3 as the highest common factor, then the remaining terms you'll have to keep inside the bracket. That is, we left over with 1x plus 4, and that will be our solution here. Similarly, even here we can see here 7x minus 21y. So first we'll have to check the numbers properly here. That is 7 and 21, both are divisible by 7 table, which means we can take 7 as the highest common factor from these two terms. Next, we also check the variables. We can see here clearly that is x and y are not same, which means we can't take variable as the common. So after taking here 7 as the common here from the first term, so we left with the variable x minus, now here 7 into how many times equals to 21. So 7 into, yes, that is 3 equals to 21. Then again variable y will be left out. Likewise here we can see the next one also. 25x squared minus 125x. That means here 25 and 125 both are divisible by, yes, that is 25 table. So we are taking here 25 as the highest common factor, and we can see the variable x, even here x. Now while taking the common from the variables, what we used to, we check their powers. The least power we take as the highest common factor. So here the least power, which is x raised to 1. That means here we are taking 25x common from these two terms. Now you'll have to collect whatever is left out, and that value or the terms you'll have to keep inside the bracket. Now 25 into how many times equals to 25? Yes, 25 into 1. After that, here x squared, so we took here x already common, so just you'll have to subtract their power. 2 minus 1 will be 1. That means only 1x will be left out from the first term. Likewise here 25 into how many times equals to 125? Yes, 25 into 5 times. Now the variable here 1, here also 1. That means 1 minus 1 will be 0. That means here the x variable will not be left out here. The next one, we can see here 20 and 15. Now both this number are divisible by, yes, that is 5 table. After taking here 5 common, again we can check here the letter m, this also m, which means we can take here m variable common, but the least power, which is 5. So we can take here m raised to 5 common. Here p, and this side without p, that means we can't take p as the common. So after taking here 5m raised to 5, then the remaining part of the terms will be here 5 into how many times is 20? Yes, 5 into 4. Then the variable m, out of 10 we already took 5 outside, then again 5 more left here. So m raised to 5 minus again 5 into how many times? Yes, 3 times. Then m will be 5 minus 5 will be 0. Then we left with p raised to 6. The next one, again here the topic Same, you'll have to factorize the following algebraic expression. Even here, you'll have to take the common like we did on a previous step. Now here, what they did here, they have added one more terms. Previous question we did with only two terms, but here they have added one more terms. Now we can see the constant value first here, 21, 14, and 28. In which table we get 21, 14, and 28? Yes, that is in a which table? Yes, that is 7 table. After that, here we can see x here without x. That means we can take x as the common. Similarly, y here without y. That means even the variables y cannot be taken as the common. Now after taking here 7 as the highest common factor, then what value will be left out from the first term? So to get that, here 7 into how many times is 21? Yes, 7 into 3 followed by x square. The same sign we drop here. 7 into how many times equals to this? Yes, 7 into 2 variable x y square plus here 7 into how many times? 4 y raised to 3. We can close the bracket. Here we can see 14, 12, and 35. So here, in which table we find all these three values? Do you have any table? No. That means here 14, 12, and 35, we don't have any common table here. That means we can take only the variable x, here also x. So we can take here the variable x. So while taking the variable as the common factor, then what we used to do, we check the least power. So here the least power is 2. So x square can be taken common. Then we left with the constant value 14. Now the variable x will be left. 3 minus 2 will be 1. The power 1 we don't need to mention there. Plus again here 12. Again here x, 2 minus 2 will be 0, which means x will not left out here. And then the variable y will be left out. Minus again here 35. X here square, this also square. 2 minus 2 will be 0. Then we left with only y square. Likewise, the next one, we can see here the constant value 4, 12, and 8. All these three are divisible by the table 4. Apart from that, we can see here p square, p square, p. That means here we can take a letter p also common, and the least power among these three we have here 1. So after taking 4p common from all the three terms, then here what will be left out? So 4 into how many times? 1. So we don't need to write here 1. So then we left with the variable p, because here 2, here 1. So 2 minus 1 will be only 1. Minus again 4 into how many times? That is 4, 3. Then the variable, again one more p will be left out. Moreover, the variable q square also, minus 4 into how many times equals to 8? That is 4 into, yes, 2. And the variable p we already took out common, because here 1 minus 1 will be 0. The next one here, again we can see here 9, 54, and 81. All these are divisible by the table 9, and that is our highest common factor among these three. After taking 9 as the highest common factor, from this term what will be left out? Only x square. Plus after taking here 9 as the highest common factor from here, then the remaining will be 9 into how many times equals this? Yes, 9 into 6, 54. Then the variable x will be left out. Plus again 9 into how many times? 9, 81. Likewise here, the next one also, we can see here the constant 5, 10, 25, and all these are multiple of 5 table. So we are taking here 5, the highest common factor. Along with this one, we can see the variable y, again here y, again here y, which means we can take the variable y also common, and among these three, the least power, that is square. So we are taking here y square common. Now z, but z here missing. That means here after taking here 5y square, the highest common factor among these three terms, now the left over here So 5 into how many times? 1. So we don't need to write 1 here. Then there will be only y to the power, yes, 1. Plus here 5 into how many times? 2. Then the variable y will be left out from 4. We already took y square outside. Then there will be 2 more y here. Again z will be left out. Plus here 5 into how many times? 5. Then y will be 0 because we have here y square and we took y square as the common. Then we left with only z square. Now we can see here the variable x. That means we can take here x common, but among these three the least power we have here square. Likewise y. That means again here we can take y, and among these three the least power we have here cube. Now after taking x square y cube from these three terms as the highest common factor or the common, then the remaining from this term, then x, how many x will be left out? 4 minus 2 will be 2. Again here y will be 4 minus 3 will be 1. Minus, now here how many x will be left? That is 3 minus 2 will be 1. Again y to the power will be 5 minus 3 will be 2. Plus here x, 2 minus 2 will be 0. That means y will be y cube, here also y cube. So nothing will be left out, which means we can label there 1. The third one, factorize each of the following algebraic expression. So even here we can see p within the bracket q minus r plus p within the bracket q minus r. So here also you'll have to take the common factor. So we can see here the factor q minus r, even here q minus r. So we can take here the factor q minus r as the common factor. After taking q minus r common factor, then we left out here p, and here the sign plus again here, which is equals to the letter p. So here q minus r not possible to subtract, so we drop the same here, but on the other side here we can, it's possible to add because these two are like terms. 1p plus 1p will be 2p. The next one, we can see here the factor x minus 2y. Again here x minus 2y, which means these two are same. So we can take here the factor x minus 2y common. Once we take x minus 2y common, then you'll have to collect the term that is left out with along with the sign here, 3x minus we have here y. So now these two are unlike terms, not possible to subtract. Even here these two are unlike terms, so not possible to subtract here. Now the next one here, that is the factor x minus 5y. Even here x minus 5y, these two are same, so we take common. That means you'll have to just take one of it, x minus 5y. After that here you'll have to collect back here, that is the term 5x, and here we have here minus 7y. Again to the other side here we can see the factor x minus 1, this also x minus 1. That means we can take here the factor x minus 1 as the common. Now what you'll have to do, yes, you'll have to collect back here, that is 3p square plus, now not possible to add here, likewise here not possible to subtract. Now the next one here, we can see here the factor, which factor is common? Yes, the factor y minus 1, which is our common factor. After taking that factor common, so what we left out here, that is x minus we have here y. Now here we can see the factor x minus y, here also x minus y, here also x minus y. That means here we can take the common factor x minus y. After that, yes, we collect back here a square along with the sign, that is plus b square. Again here plus we have here c square. Now here what you'll have to do, we have got four terms. What we can do here, you'll have to arrange, you'll have to take the common from the first two terms and the last two terms. So let's have a look here. So from the first two terms, we can see here the constant value, that is 4 as the common. So once we take here common, that is, now we left with the letter P plus here, yes, that is Q minus. Again here the sign, you'll have to drop the same sign. So what we can take here common, yes, the letter A common. So taking here A common, then left with a letter P. Here I've got plus, here also you should have to get plus, that is minus minus or plus. Then here left with Q. Now again here the factor P plus Q, here also P plus Q. That means you'll have to take a factor P plus Q as the common. So whatever value we took common in our previous step, you'll have to collect back, that is 4 along with the sign minus A. Now again here we have 4 terms. From the first two terms, you'll have to take common first. So we can see here AB square minus BA square. So we can take here a common AB. After taking AB common from these two terms, now what will be left out here? A will be 0, but B, 1B will be left minus. So here B will be 0, so A will be 1A will be left out. The same sign you'll have to drop here, minus. Now here what we can take common? Yes, the letter A we can take common. So after taking A common, then we left with B. I've got here minus sign, so here also we should have to get minus, and that sign you'll have to multiply this minus plus, which is minus. Then after taking A common, so 2 minus 1 will be 1. That means you will be left with 1A. Now again one more step you'll have to increase. We can see the factor B minus A. Here also B minus A. That means you'll have to take common B minus A. After that here, yes, you'll have to collect back here A, B. Again here minus, we have here A. Again we can see here these two not possible to subtract. Again not possible to take common. But here A again we can take common. So B minus A, taking A the common here, so we can keep at the side here A as the common. So after that here there will be left with B minus A into 1. Factorize each of the following expression. Sub question number 1 here, A square minus 6AB plus 9B square. So for these questions you'll have to recall the identities of, that is A square minus 2AB plus B square, and that equals to, yes, A minus B the whole square. So the given expression here, that is a perfect square trinomials. So you'll have to convert in this form, that is A square minus 2AB plus B square. So the first step, see that whether it's a perfect square or not. So this can be just taken here A square. Now we need B square. So here with this you'll have to get a value B. So we know that 9 is a perfect square of, yes, which number? 3. So that is 3. It has a variable B. So now we take here B square. After getting here B square, then get a value of 2AB. So same sign we drop here minus. So we can see here A square I've taken minus minus. After that 2 into A into B. So now 2 into A. A means here only this value. Into B means only 3B. After that plus B square. So plus B square. So the given expression I've converted already in the form of A square minus 2AB plus B square, and we can see here clearly, and that equals to A minus B the whole square. So here A, which means that also A sign will be the same here, minus B means the value is 3B the whole square. Or we can also increase further step, one more step. Now A minus 3B whole square can be also taken a minus 3b into a minus 3b. Now the second one here, taking the same formula here, first try to know the value of a and b. So again, try to recall the formula here. You'll have to take in the form of a square, since it has a minus sign, so we take here minus 2 into a into b plus b square, and that implies to or equals to a minus b the whole square. So with this value you'll have to get a, and here with this value b. So first get the value of a and b. So now we know that here m square can be just simply taken here m, and 4n square, we know that 4 is a perfect square of, yes, 2, and here the variable n we keep, so 2n the whole square, which means I've changed this or converted into b square. Now after it, minus sign, what you'll have to do, take 2ab, so that means here 2 into a means only m, into b means only 2n, followed by plus b square, and that equals to a minus b. Then here m minus b means here the value 2n, it has whole square, or this can be also taken here m minus 2n into m minus 2n. The third one, so first thing you'll have to know a and b properly. So here with this you'll have to get a value of a and here b. So I need here with this one a square, with this value you'll have to get b square. After the same sign we drop here 2 into a into b plus b square. Now here the value will be only xy, and 9 is a perfect square of, yes, that is 3z. So I've got the value of a also, b also. Now here filled with 2ab. So 2 into a means xy, b means, yes, that is 3z. We know that a square minus 2ab plus b square equals to a minus b. So here a, that is xy minus sign, b, which is equals to 3z the whole square, or this can be also taken here xy minus 3z, again here xy minus 3z. 36p square plus 36p plus 9. So the given expression is already a perfect square trinomials. So with this I need to form here a square. With this you'll have to get here a b square. We know that 36 is a perfect square of, yes, that is 6, it has a variable p, and 9 is also a perfect square of, that is 3. Now the same sign you'll have to drop here also, even here the same sign. Now this place you'll have to fill with 2 into a into b. So I've got here a square plus 2 into a. A means here 6, p into b means that is only 3. So you can verify and see 2, 6, 12. 12 3s are 36p. Automatically we get the middle term. Now after getting this one here, we know that a square plus 2ab plus b square equals to, yes, that is we only take a, which means 6p. The same sign you'll have to take here, plus, which is we have here 3 the whole square. Now the next one. Here again perfect square trinomials. Convert this into a square minus, with this we need here b square. So now I've already kept here square, but here x raised to 4. That means there will be another 2 more x. Now here 81 is a perfect square of 9 9s are 81. Then already I've kept here square, so y will be 2 more y square because y raised to 4. Now minus, you'll have to fill it with 2ab. So I've got here a square minus 2 into a. So a means within the bracket here, that is x square, into b means here within the bracket 9y square plus b square. We know that a square minus 2ab plus b square, and that equals to a minus b, which is 9y square. After that, a minus b the whole square. Now again here, again we have our perfect square trinomials. This can be converted into a square, and to the other one will be b square. We know that 4 is a perfect square of 2. It has a variable p, and here fractional 1 is a perfect square of 1. 4 is a perfect square of 2. That is how I've got here a square and b square. Now the same sign we drop here, plus. After filled with the formula a square plus 2 into a, which means 2p into b, which is 1 by 2, plus b square, and that implies to, yes, a plus b. B means here 1 by 2 the whole square. Or we can also write this 2 times, 2p plus 1 by 2 into 2p plus 1 by 2. The next one here. Now 9 is a perfect square of, yes, that is 3x, and 16 is also a perfect square of 4, so 4 square. Minus sign, minus sign. So I've got here a square minus 2 into, yes, a, which means 3x, into b will be 4 plus b square, and that implies to a, same sign you can drop here, minus b, which is equals to 4 square, or you can also expand the same factor. We can write 2 times, or we can also just stop here also. Okay, flashback the formula here. So with this given expression, and the given expression is a perfect square trinomials. Firstly, you'll have to convert this into a square minus 2ab plus b square. Now here, because it's already we got here, that is we have the x plus the whole square, which means a square. So I've got the value of a, so x plus 2 the whole square is our a square, minus minus, but I need to know the value of b. So that is 9 is a perfect square of 3 square. Now the same sign we have dropped here. Now we don't need to worry about the middle term. Automatically we get this factor here. So a square minus 2ab. So 2 into a. A means the factor x plus 2 into b. B means only 3 plus here b square. Now here we take only, after that here, a square minus 2ab plus b square equals to a minus b the whole square. Now taking these identities here, now a, which means x plus 2, minus sign, b we have here 3 the whole square. So we can see here that is x plus 2 minus 3, plus minus will be minus, 3 minus 2 will be 1, but signs will be, yes, minus, because we take the sign from the bigger value, so which is it has a negative, so the whole square. And here 3x cubed minus 30x square plus 75x. Now is it a perfect square? No. Again here, is it a perfect square? No. That means what you'll have to do here, first you'll have to take the highest common factor from the given term. So 3, 30, 75, and all these numbers are divisible by 3. After that here we can see the variable x, here also x, even here x. So we are taking here x common. So after taking 3x common from these three terms, then we left with, from the first term we left only x squared minus 3 into 10. After that here, x plus 3 into 2, 6, 1 in n, 3 into 5, x will be 0. So that means here, again we drop here 3x. Now you'll have to work on this expression here. That is, I've got now perfect square trinomials. Here also perfect square, here also square. Now here, with this you'll have to form the identities. A square minus, we know that 25 is a perfect square, 5. So 5 square. A square minus 2 into a. A means only x. Into b means only 5 plus b square. And that implies to 3x. You'll have to drop here. Now a square minus 2 into a into b plus b square equals to, yes, that is a minus b the whole square.